Everyone, and welcome back to the Hypertwins. As you see on the screen today, I have Steve with me, one of my lovely colleagues who will introduce himself in a second. But today with a very special topic on doing bill of materials or offer reviews from our beloved hardware vendors. And Steve built a really great guide for the team, which we also wanted to share with you as a community. But first thing first, Steve, please introduce yourself. Where are you? Where are you located? And tell us about yourself.
Yeah, hi everyone. Yeah, I'm Steve Swallwell. I'm based out of the UK. Part of the FastTrack team, have been for around 14 to 15 months now. It's my first role in Microsoft. Prior to that, I worked at an MSP, so doing lots of customer work, customer deployments. Had lots of dealings with Azure Stack Hub, which is where my cloud interest came from. So Azure Stack HCI was definitely the next step, sort of, for me to move on with things. But yep, pleased to be here.
Thank you so much for joining me today. And yeah, let's firstly, why do we do those BOM reviews, or why do we support customers with those BOM reviews? I think most of your experience also with the data center stuff. So what are our main drivers to do that?
So again, I think the key thing is there's different types of hardware. You can have integrated, validated, or you can almost have a bring your own. And what we need to do is make sure that what has been specified, even if integrated or validated nodes, it's going to meet the requirements of the customer when it comes to networking, when it comes to storage, performance. So I think it's key that just a second pair of eyes, taking a look at that list of materials to make sure that that everything's been, all the guidance has been adhered to, but also from our experience working with other customers where we may see certain configurations where the performance or expectations hadn't been met by the customer. So we can just give some pointers, say, well, maybe you want to look at some additional network cards or maybe slightly different hardware architecture.
Yeah, so I think a good comparison here is our intern is saying, what we try with those BOM reviews is putting the customer on the right train. So if he has chosen for the wrong train, every station, every stop afterwards would be the wrong one, and you would travel in the wrong direction. So normally, when working with Azure, doing everything on consumed revenue, that's not an issue. Just tear it down, build it correctly in the second place. But as we're dealing with hybrid here, and you need to order systems, you need to pay for them, and to be honest, an investment into hardware isn't cheap. It could be that you order the wrong one or the wrong systems, and either cannot give them back, so you have expensive play toys catching dust, or you need to have excessive discussions with your hardware vendor to replace parts, revalidating systems, and so on. And that's I think we saw a lot during our first 2 years doing HCI now, together with the team. And yeah, that's basically what our starting point is.
Yep.
Yeah. So, Steve, maybe you want to share your Visio in the meantime. To all of you, when watching that video, so currently we're working with a Visio file as a mind map, as a guidance within our internal team. We will also work on a maybe blog post or a Power App that you can use outside of our team or outside of what we are doing here. Maybe we will also upload the Visio file Steve is using here. And if that happens, just take a look into the video description. I will link it there, also to Steve's profile. So if you have any additional question to the templates or want to add something, give us feedback, what we may be missing. Just use the comments or ping Steve directly then via LinkedIn. Yep. Okay. Steve, you already mentioned there are different type of systems out there. There's integrated, validated, or you also mentioned other. So what's the reason behind that?
Yes, so basically integrated and validated are when it comes to the hardware, they're pretty much the same things. So the hardware will have been reviewed by the hardware OEM to make sure that it meets all of the requirements, some of which we'll go through sort of on this flow diagram. And it's things like are network cards supported, or are the disks at an adequate speed? Does the processor meet requirements? Yeah. So, but the main difference between validated and integrated is the integrated one. It goes that one step further. So, for example, the integrated systems come delivered with the operating system installed, with the firmware updated to the required level, so it's all matching across all of the systems. The drivers will be installed into the OS, so again they're ready and ready for you to go sort of straight into your deployment. Whereas the validated system, it would just be like buying those same hardware nodes, but just off the shelf. So they would be delivered to you. There may be that there's different firmware versions across. You need to install the operating system. You need to install the drivers required. Because Azure Stack HCI operating system is core-based, sometimes that can be a little bit difficult to find out the process for installing the correct drivers that you need. And also with the integrated system, there's a tight join between Microsoft and the hardware OEM. So again, you can log support calls either way. So if you've got a hardware issue, you could log it with Microsoft, and if it turns out it's a hardware issue, that would then go across and be provided, or they can then liaise with the hardware OEM to give them the level of detail they would need to identify the problem. And again, the same the other way around. You could log a call with your hardware OEM, and then they would go off and take a look at, and if it's software, they can open up that dialogue with Microsoft. So they're the two main that we go for, that we would suggest. But I think the other is kind of a build your own. So what you need to do is you would need to look at all of the requirements, all of the hardware requirements. You would then need to try to identify the hardware that you need, that's supported, and then you would then go on and you would have to update firmware and the install the operating system and the drivers and things. But that's a lot more of can be a lot more troublesome, because again, you've got to identify that hardware, and also you might identify some hardware, but it might only have a 1 year lifespan remaining. So that means in 18 months' time, if you have an issue, you may not be able to get your hands on that hardware, and because the hardware needs to be symmetrical across all nodes, that could then become difficult, because you could have one failed hardware part, but you're having to replace multiple parts of the hardware because of the inability to obtain the same one again. Whereas that's covered by validated and integrated, because the hardware OEM is picking hardware that they know has a reasonably long lifespan remaining.
Maybe just to mention here on one of my other videos in the FAQ series, I'm describing that there's, with most of the vendors, you can have a 7-year lifespan for the hardware and availability. So that's depending if it's mainstream systems, yeah, most likely there's a 7-year or 5 to 7 year lifespan. Maybe to catch that up here, the only supported options for HCI are integrated and validated nodes.
Yeah.
If you want to build it your own, yes, then do it, but never for production use. If it's a lab, if it's just a testing, so Steve and I, we also run our home labs. I'm running it on Intel NUCs. Bernhard on the series is running it on old data servers which are not supported. I think Steve has also at least some virtual machines nested running in Azure. So those are valid options for testing, but those are no options for production.
Yeah.
And especially from a FastTrack perspective. So if we as a FastTrack team only engage on integrated and validated. If you want to do it on your own, on unvalidated, uncertified hardware, yes, do it, but that's normally something we will not engage, as we do not expect to be a production system here. And that's also one thing you will get from the support if it's not running on validated integrated hardware. They will say, okay, it could be hardware, could be software, but in this case, please, check it on another system. So just as an example, Steve, let's go through the examples of integrated. So there is Dell, definitely with integrated nodes.
Yep.
We have Lenovo data on, and with HP, it's a bit special. HP has validated and integrated nodes. Validated nodes, they are normal power, forgot the name. They're on regular servers. They're normally validated in the solution. But if you're, for example, buying HPE GreenLake, you will get an integrated system from HPE. And maybe also a fun fact with the integrated, or a good thing with the integrated, most of our integrated partners now have their management tools like Dell Open Manage or HPE or Lenovo tools. They're integrated in the Windows Admin Center. So they will also have integrated firmware updates and so on. So it's a fully integrated solution in this case.
Yep.
So I think that point is clear. We have also some other videos on the channel. I will link them below. What CPU can I use? Can I just grab my capturing machine here and say, okay, it's a Core i9 and just run it from there? Or is there some recommendation what we would normally look for? What is the thing we expect?
Yeah, really what we're looking for is kind of server grade CPUs. So you're looking to your the Intel Xeon or the AMD EPIC grade processors, just so that you know you're going to get the sort of the latest, and again the latest feature sets of those processors to make the most of the virtualization platform.
So even with the older processors, so especially so Xeon Nehalem would already work, but it's not on a validated system. So
Yep.
what you often see here, so I think the earliest version of EPIC is currently generation 1, and for Xeon it's the scalable Gen 1 or the first scalable version. So currently we're in a generation change when it comes to CPUs. So what I would think of, especially when you're working with a vendor who has already validated newer generations, I would always jump to the newer generations because of the extended lifespan when it comes to the processors. And especially with the, I think it's the new EPICs, Steve, correct me, or it's the new Xeons. You can have much more PCI lanes, much more PCI cards in your system, which gives you a lot more options, for example, for storage controllers.
Yeah.
Or for network controllers. So, Steve, so let's just quickly cover that. So we would expect enterprise CPUs,
Yes.
Xeon or EPIC within the system. And from a core perspective, you can always size with your partners. When it comes to physical to virtual core, I think the industry standard for common workloads is 1 to 4, so 1 physical core to 4 virtual cores. And when you're, for example, running databases like Oracle, SQL, Postgres, MySQL, etc., it's a 1 to 2 ratio, so 1 physical core to 2 virtual cores. So that's the industry calculation standard. At some points, correct. Sometimes maybe undersized, maybe oversized. That will bring over time, but that's what you need to do for the scaling.
Just another point on that. I think one of the key things to remember is what type of resiliency are you looking for, so that again, if you're going the sort of the 1 to 4 ratio, is that bear in mind that you want to tolerate at least 1 node failure and not impact your production workload. So again, and also to allow for growth of your environment, because we all know once you've got your virtualization platform, there's always extra VMs to be deployed, or you need to upgrade VMs because a new version of the application's been released, which now needs more processing power. So again, it's just don't look at what you've got now as a baseline. Consider growth. There are expansion options, So you can add additional nodes if you need more CPU or memory requirements. But again, just keep an eye on that of what your long term. If your hardware is going to hoping you're going to last you 5 years, maybe just try to have a little look out into the future, get that crystal ball out, take a look what might you be needing in 2 to 3 years time, and try to scale accordingly. And also when it comes to your design, make sure that it's going to be easy to scale, so that you're not going to, if you suddenly need to add an extra server, you're going to need to buy lots of new NICs or different switches. So maybe try to plan that at the beginning, at the beginning of your investment.
So when looking on that, so we will talk about the storage later. I think you have a great point here in your mind map. So normally what we see, we're not running out of memory. We're often running out of storage. And for that, we need to cover a few additional things, as we will cover later in this video. But let's talk about memory first. So normally you would like to cover the memory of your virtual machines. So normally, depending, it's now 1:2, 1:1 ratio, depending if your machine can use resizable memory or not. But there are some requirements in addition we normally check, Steve. So what would that requirement for memory, what we would check?
Yeah, so again, you're looking at maybe around about the 8 GB mark just for the operating system to be able to run. But also there's a recommendation that when it comes to your storage, if you have a cache tier, that for every terabyte of cache in your storage, you have 4 GB of RAM that can be used for that caching mechanism. So again, so if you had 2 terabytes of cache per node, you would need to look for 8 GB for your operating system, 8 GB to cover your cache. So straight away, without running any workloads, you need to be running with 16 GB of memory. So we normally sort of see customers are normally coming around about the 256 gig per node mark. That's normally sort of what I'm seeing customers come in with. But again, that's depending on the hardware. That's fully scalable up to even terabytes of memory per node.
So in general, we will also talk about the chassis sizes. But if you do not have any concerns when it comes to rack space, what we encountered is that a 2U system or a larger system is a much better met for requirements and for expandability than the 1U systems like the Dell AX 650 or the 680, I think it with HPE. So if you're not in a concern of having a high density requirement, often it's a better use to have the larger systems. In edge scenarios, perfectly fine to having two systems running in your store, maybe on 1U with not that much requirements. You often also see 2 systems on 1U with the SE350 from Lenovo, but it's often a data center we're seeing the requirement for or growing, especially when we're later talking about storage, that we would need the larger chassis to have more or to have more space to grow, and especially also have the larger motherboards in this case with 2 more or 4 more memory slots to add additional memory later on. Maybe from an investment point of view, it looks like a bit more expensive in the first place, but on the long run, if you need to purchase a new server in 2 to 3 years and it's no longer available, either you need to get something which is still in stock at a partner or so, maybe with a limited support. You need to buy something on the second market, or you maybe need to buy a whole new cluster when you want to have the same nodes or the same systems throughout your cluster. So going larger with more expansion space is a good choice here. Okay, why do we ask about NICs? So especially Bernard could tell stories about that.
Yeah. So with the NICs, the network, because it's hyper converged, is key. Because everything's reliant on the network, your storage, your compute, your management. So basically, the first thing we look for is that the NICs are within the Windows Server catalog. So again, they need to be supported via with the latest server operating system, so that you get all of the features that are required. And then additionally to that, there are three types of traffic which the NICs need to support. So they're compute, storage, and management. Now, depending on which design you go for, you may need a NIC. So if you went fully converged and you just had a pair of NICs, which you then had a set switch and you had your storage, your management, your compute, that NIC would need to support all of those standards. But what you can do is you can then break that down to go and break your traffic up so that you have dedicated NICs for your storage. So again, they would just need the storage capabilities and the validation that they support the storage aspect. Again, you can have separate for management, and they would need that. And then again, compute, you would need one compute on NICs that support the compute standards. But you can then start to mix and match. So you could go for dedicated storage, so per 2 ports for storage per node, but then you could have 2 ports which you use for compute and management. So again, it's key that you tick all of those boxes, that you support those three types. Also, the next thing is about the NICs need to be symmetrical. So you need to have the same NICs going down as far as make, model, firmware, and driver versions on there. Again, that's because to create the highly available switches, the set switch, those need to be symmetrical. And again, this goes back to those validated and integrated systems. They will make sure or can help make sure that they are available. So as I said, there's sorry, go ahead.
Maybe also worth mentioning here, even if they have the same firmware, if they have the same chip and so on, you can also not mix LAN on motherboard chips with PCIe chips or PCIe NICs, because they're often not, let's say, connected to the CPU in the same way. It's with some servers, with some motherboards, those systems, especially when you have an Intel, they have a chipset on motherboard which expands the PCI lanes, so they can add additional cards. And the LAN on motherboard is normally directly integrated into the CPU. So please be aware that you can also not mix and match PCI and LAN on motherboard. Here in this case, from a vendor perspective, especially when talking about RDMA, so without RDMA, I think everything is perfectly fine. But Steve, we know we had some trouble, for example, with the Intel RDMA cards recently due to driver and firmware issues, and we are still seeing that. So we have August 2023, and we are still seeing some driver issues. That's one thing we also mentioning to our customers. It may work or may not. So that so a good bet here when working with RDMA cards is still NVIDIA Mellanox. Marvell is doing a good job, and also Broadcom. Intel, most of the hardware partners already removed the Intel cards from their offerings. But if you're seeing those really question your partner if that issue with the drivers and firmware is already resolved when watching that video and when talking to your partner. If not, exchange the cards. And maybe one thing, I don't know if it's only me, but Steve, driving that one. So we are not only talking about the high capacity cards like the 10, 25 gig cards, but normally every motherboard has 2 1 gig LAN on motherboards.
Yep.
I'm a friend of using those for management, heartbeat, and maybe backup or something like that. would it be and also a recommendation you would drive to use every port you have available on your system, or is just leave them empty?
Yeah. So I think if those ports are there, make use of them. As you say, if you move things like management and even back up onto some onboard ports, which may be only 1 gig, that gives you the option. You're freeing up bandwidth on your other ports. So again, you're not taking some of the bandwidth for backup traffic from your compute, the cards which are dedicated for compute. So yeah, I think if those ports are there and are available, make use of them. Again, it can depend on, because sometimes customers are using existing switches, so port availability could be limited. So again, it may be that you don't have capacity in your switches, in your top of rack switches, but yeah, I think if you've got the ability to use those ports, yeah, definitely. But again, if it's something like just maybe a 1 gig port, keep that for heartbeat or management or backup, and then and then keep your higher bandwidth ports as 10, 25 gig ports for storage, for your compute, for replication if you're going for a stretch cluster. Yeah, so I would definitely look to use those where possible.
It's also saving up some money. So if you're looking on the port prices for the larger ports, you will see that, for example, a 1 gig port is it's normally only an operational cost from a few cents per month. I think in Germany, I don't know how it is in the UK. It's 75 cents per month for a 1 gig port. And when you look onto a 25 gig port, it's around €4 per month, which is the calculated data center cost per port. And if you can free up those with cheaper ports and then have more bandwidth available, it's more or less also a cost saving on the long term.
Yeah, that's it. So I think the next bit of the diagram, it starts to get a little bit, although we're discussing hardware, it starts to look at your design. So when it comes to your storage, you can go switched or switchless. Now, depending on if you go switchless, we're directly connecting the nodes, so the number of network ports that you need starts to increase, and the more number of nodes that you're having in your cluster needs to increase, so that you can get the direct connectivity between each of the nodes for the storage network. So again, this part of the diagram sort of goes through that. If you're going for 4 or more nodes and it's switchless, that really you need to maybe reconsider your switch design and go for a switched storage network. Again, then go across if you have 3 nodes, that ideally you need to be having 6 or more ports, so that you can get your cross connections for your for the storage and have a full mesh for your storage, so you can tolerate some of those links going down but not lose the connectivity. Again, if you're going 4 or 5 ports, again it will still work, but you're not going to be able to have that full mesh for your switchless configuration. And then again, if you've got only 3 or less ports and you've got a 3-node system, you can't go switchless, because you need to have dedicated storage, and then you should be still looking at 2 ports for computer management to give you that high availability and resiliency.
It's also not even if it's working, it's not recommended, because if you for example needing 6 ports for full mesh configuration, you would also need to have 6 additional network subnetworks you need to manage, need to correctly cable and set on the other sides. So it doesn't make any sense to go switchless with more than 3 nodes.
Yeah. I think the benefits of going switchless, so you'd sort of not having to have switches that support the switch configuration and things like that. Well, I'd say once you start, as you add extra nodes, you're needing to add the number of ports you need to start to go exponentially, so that it's not just a case of adding 2 more ports when you add a new node. You need to make sure that every node has at least one direct connection to every other node. And really, you need to be looking for 2 connections. So again, it starts to become the cabling and cable management becomes difficult. The carving up your subnets and your networking becomes difficult. So 2 or 3 nodes, go switchless. If you need to, but anything above that, we would definitely recommend to go for a switch configuration.
Yeah.
You can migrate between the 2, but again, that is going to be a lot of work. Potentially some downtime to the customer while you're recabling things and adding extra NICs. So again, it's maybe better to consider that at the beginning, so that you're ready and can. So if you need to add those extra nodes, you're able to without too much additional work.
So
Yep.
Staying with our scenarios, so where you maybe see switches, where you maybe see switched. So switches we're seeing really often in edge scenarios where we have a small cluster running somewhere at the edge, or in a small medium business company who only has a few nodes, or even a stretch scenario where you have 2 or 3 nodes on one side, or 2 and 3 nodes on the other side. So there we often see switchless. When we are going to larger deployments within a data center, or even within larger size, we are seeing more the switched configuration. Also, when you look again on the cost perspective, those Mellanox cards or those Marvel cards are highly expensive, and as you add more cards, maybe a switch becomes more affordable than adding more cards.
Yeah.
Also calculating the management overhead, possible downtimes, and also a migration or a zero downtime migration from one to another is possible with some really getting your brain and head around that, but it's possible. But yeah, as you already said, it's better planning ahead and planning the expansions you maybe want to do in 1 year, 1.5 year, already in your design now, to make an expansion easier, and also saving labor time. Again,
yeah.
It's also one thought process we always have when we go through those review processes and discussing about the customer's future with those clusters, with those systems, is what are your plans for the futures? Okay, what do you need to invest in labor time when you want to upgrade it later on in 1.5 year maybe? Is the person who did the whole configuration still there? So let's say you get someone from Dell, configure the whole cluster, knows everything, and he will not be available 1.5 year to help you increasing the cluster, redo the cabling and so on. Maybe also losing documentation, which is, IT documentation. We all do it right, but we lose it at some point in our careers. So always calculate that in mind. Always calculate not the best case scenario. I'm personally a worst case guy. and calculate those labor costs into your current offers. How much would it cost me if Steve would come for 2 weeks to do the recabling with 1,500 British pounds per day or per hour, Steve per hour? So yeah, maybe it's affordable to have that switch and these stack cables already.
Yeah. Again, I think with this, it's looking to the future. Don't look at your immediate requirements. Maybe have a look how you would expand and move forward into the future. So I think the other consideration, so we've covered off switchless, is going for a switched configuration. So as we go through, you can do a switched configuration with only 2 NICs. So you would have a fully converged network topology where you would create a set switch with those 2 NICs, and then you would have storage interfaces and your management and your compute interfaces all on that set switch. But with that, what we do recommend is that really should be 25 gig or more, basically just so that you've got enough bandwidth for your storage and your compute, and you don't want those 2 to interfere with one another. There are CORS policies where you reserve certain amounts of bandwidth for storage and certain for your management, and then the rest is available for compute. But again, we find it is to go for those, even with just a two node switched environment would be go for 25 gig NICs. The next one is if you've got 4 or more NICs.
Maybe add a comment here at this point. Again, back to my retail example. Yes, so maybe also 10 gig is fine, but it's really also depending on your workload. If you're just running a domain controller and maybe some system for your cashier, or maybe just a file server, 10 gig might be okay. But I would really recommend to talk to a partner and do some quick I/O calculations if that works out for you. I said what we encountered is, even with a 10 gig on 2 node, having a lot of machines running, having file servers running, having data centers running, especially with those servers like the AMD EPYC servers where you have really hundreds of cores in one system, a lot of memory in one system, more than 2 terabyte right now. If you really full stack that one, it could be that you have 50, 70 virtual machines running on one system with a high amount of changes, and then having a hyper-converged configuration that could really have an impact on your storage I/O.
Yep.
And that's really also look onto your workload. And is that with a fully blown node, it could happen that you're ending up with a demand for more network traffic in fully converged. I said if it's just sitting down there in a shelf, serving as a domain controller and maybe for your cache systems, 10 gig might be fine. But as I said, if there's more planned in the future, you maybe will run in a bottleneck with that. That's why we always look for the 25.
Yep. Yeah, and then the next option is when you've got more NICs available, so 4 or more NICs. So again, this is where what you would do is if you had 4 NICs, the first thing you would look to do is break away and have dedicated NICs for your storage. So this is what we're going to look at. So the first part, well, mainly is your storage NICs. That really, if you've got 3 or more nodes, then what you should look is again be looking for those up sort of 25 gig or above NICs, just so you can handle the amount of storage replication that's needed between those nodes. If you're just going for you just have a 2-node system, yep, we would recommend a minimum of 10 gig for those storage networks. Again, just so you haven't got any consideration about are you going to have enough bandwidth for all of the storage traffic. And then what you would do is you would use 2 NICs for storage, and then what you could look to then do is then however many other NICs you've got, as Flo mentioned, you may have 2 10 gig NICs and 2 1 gig NICs. What you might look to do is create a set switch with your 2 10 gig NICs and have that just for your compute, and then use your 1 gig NICs for your heartbeat and your cluster management. And then or what you could do is go for a set switch, and if you only had 2 extra ports, and have compute and management on those NICs as well. So again, it's just really the key one is around the storage network. If you're only 2 nodes, yeah, so you most likely get away with having 10 gig NICs. But 3 nodes or above, we would definitely recommend going 25 gig on those storage NICs.
Perfect. So in the next step, you're mentioning stretched cluster. How does the stretched cluster impact our decision making when it comes to especially network design?
Yeah, yes. So I think the first key thing is with the stretched cluster between the 2 sides or your 2 locations, you need to have sub 5 milliseconds round trip time. So again, that is a key thing that you need to consider, is that it doesn't matter what hardware you purchase for each site. If you can't provide sub 5 milliseconds round trip time, a stretched cluster isn't going to really work out for you.
Or
and
an
then
active stretch cluster, basically, where both
yes,
sides are active. So if you would pass these 5 milliseconds round trip, then it would be an active standby where one side is serving your machines and the other side is more or less idling around until failover.
yes, yeah. So, and then when it comes to the hardware side of things, so what you need to consider is that you need to create some separate, or you need to have some interfaces for your replication traffic. So again, it's advised to have 2 per node. What you can do is you can either have dedicated, so that you can that you just have 2 dedicated NICs, similarly the way you could do with storage, which would only handle your replication traffic between the 2 sides of your cluster. Or the other option that you have is that you could have a set switch. So you could, if you had 4 NICs, you could go 2 dedicated for storage, and then you would have your set switch, which would be your compute and your management. Then you need to make a decision where you're going to put your replication networks. You could either add a set switch to your storage and then use those 2 NICs for storage and replication. But potentially you're then adding a software layer of your storage network. So if the storage performance is key, that may not be appropriate. The other option is to add some additional virtual interfaces to your computer management switch. But again, with with both of those options, you need to validate: are you going to have enough bandwidth on those interfaces for all of the traffic types that you require, such as so again, you could end up having compute, replication, and management on one interface. Now, if that's a 10 gig interface, you may struggle, because when we think with a stretch cluster, every write that is sent to the storage is also sent across the replicate interface. So if you've got a 25 gig pair of storage interfaces, it is theoretical that you could get 20 gigabytes of traffic going through that storage interface, and that needs to be available for replica as well. If not, the replication can fall behind. It can catch up, but again, if you're falling behind on the replication too much, it can have an impact on the performance of your storage, because with the stretch clusters, especially with synchronous, the write isn't confirmed until the replica has been written to as well. So again, that is key. And again, the decision we have here is, again, do you have enough network capacity to handle that replication if it is a shared, if you don't have dedicated replication interfaces?
Just go again, doing a short scenario thought around that one is, just imagine you're already doing business hours, your network interfaces are always at the edge, always struggling, and you have your replication is not catching up. Normally via nighttime hours you're catching up, you're perfectly fine after nighttime, and you're perfectly fine when you start your business. But maybe at some day or at some point you change the cleaning lady and she has a different rhythm of business and does not know where she can put her vacuum in, and she's just pulling the plug from your rack, and your servers are going down and your remote side is coming up because of that. It could happen that your replication wasn't catching up and you have maybe an older state from a few minutes ago, and it could just destroy your all over experience. Another important point to mention here is not every workload needs to be replicated. So if you want to save bandwidth on your interfaces, not every workload needs to be replicated. Everything which can build an application cluster shouldn't be replicated. So like Active Directory is the perfect example for that. Active Directory domain controllers does not like to be replicated. Just have a volume which is not replicated to the other side. Put your domain controller there and have the same on the other side, or have it outside of something of your cluster, and then use it there, but do not replicate workloads which can serve a cluster, or normally you call it application cluster, outside of any replication or disaster mechanism. Just try to keep them outside of those areas. It could harm you more than it helps.
Yeah. So again, just to build that, have those stretch volumes as being a catch-all. So if you have any applications that you can't do high availability at an application level, that's when you could look to use those stretch clusters, and again, that could help reduce that amount of replication traffic. So I think we've cut off all of the compute, CPU, memory, the network. So the next area I think we're going to look into is the storage. So I just bring the so again, one of the first things we look for are that normally
maybe we can in storage we have a lot of text, so maybe we can zoom in a bit so that the audience can see that a bit better.
Yeah, no problem.
Thank you, Steve.
Okay. So the first part is around the storage controller. So what you need to do is your storage controller can't be in a sort of dual state. So a lot of modern storage controllers, you can have some ports which are part of the controller which allows you to have a RAID configuration, and then the other part is just a JBOD, just a bunch of disks. The disks which are passed through for storage spaces direct can't have any sort of RAID configuration on them. But what you would probably be looking to do is have a mirrored pair of disks for your operating system. So if you have a disk failure, your operating system is still going to survive that. So again, what we look for is to look for that separate controller. So you have one controller which would be for your operating system disks, where you would have a mirrored pair, and then the second storage controller would just pass the disks through. It doesn't need any RAID capabilities or functionality because all of that is handled at a operating system level in the software.
So what we basically have here for the operating system, we have a classic RAID.
Yep.
And normally most modern motherboards from the vendors already have those RAID controllers on chip. So in most configurations you don't need to have an extra one. And then you will have the additional HBAs which provide you with the lanes for your disk or in this normally we're seeing a lot of NVMe's or SSDs, so flash stuff. We will also talk about hybrid storage configuration versus full flash in a few minutes, I think.
Yep.
But that's what we normally see. We see one dedicated controller as an HBA for disk management of your storage pool, for the software-defined storage, and then having a classic RAID controller, I would say, handling the two flash or disks devices for your operating system.
Yep. Yes. So again, the next step we look at is, as Flo just mentioned, you do have the option of going for a hybrid storage configuration. So again, hybrid would be if you have two types of storage, so SSD or NVMe. One thing that you need to sort of remember is that if you just have traditional hard disk spinning disks, you have to have a cache level, whether that be SSD or NVMe. You can't just have traditional hard disks as being your entire storage system. So again, if you go down, if you do have traditional hard disks in your storage solution, part of your solution, you need to make sure you've got either SSD or NVMe disks to be part of that cache level. And again, if you don't have those, again, you would need to speak to the hardware OEM to get that done. And then I think if we can't remember if we covered
Just
it. Yep.
Yeah, just moving back to, and there will be additional video about hybrid versus full-fledged configuration. But when we're looking on those bombs, our considerations again here, what workload do we run?
Yeah.
Normally, what we encountered is hybrid configuration is particularly pretty slow, especially if you're running out of cache tier. So what we think or what we encountered in a hybrid configuration, it's good for classic things like file servers, backup stuff, or archiving, because there you have a lot of cold data. Those cold data will be moved to the spinning disks, so that it will just laying around there, write once, read never, basically. But if we have active configurations, like we are running Kubernetes, we are running Azure Virtual Desktop, we are running application servers, we are running databases, we have all active disks. And in those cases, it's a better choice to move to SSD plus NVMe or a full-fledged SSD or NVMe array for performance and also reliability. So those NVMEs or SSDs survive much longer than even enterprise disk. And also they don't have the high bottleneck with the SATA interfaces, because especially the NVMEs have dedicated PCI lanes or PCI lane expanders, which give them a much higher performance. And it's really also depending on your workload. If you have more idle, more cold workload, hybrid may be fine. If you're really working actively, being hot, running as containers or other demanding applications and services, just go for full flash.
Yeah. I must admit, the majority of customers I work with, they are looking at full flash. And again, it's for those reasons that they need that performance, and also they don't know what's coming down the line. But as we go, when you so what you can actually do is you can still have a hybrid storage system, but use SSD and NVMe, as Flo mentioned. So you could have SSD as being your capacity disks and the NVMe as being your cache, to give you that even sort of let's say supercharged performance, so that you get the fast from the NVMe, but you don't have to commit to NVMe for your entire storage system. So one of the things that we look for is that the number of capacity disks should be a multiple of the number of cache disks, and that's to allow for a consistent balance across the across the nodes and all of the disks. So if you have 4 cache disks, you go for 4, 8, 12, 16 capacity disks, so that each cache disk has an equal amount of capacity disks, so you can get more of a consistent consistent performance. Another thing that when it comes to the cache that we look for is trying to have at least a 10% of your cache to be at least 10% of your capacity. So so you can get the most from your from the cache tier, because the last thing you want is your cache tier to keep on filling up too quickly, because then you start to lose the benefit of that. So again, we just look to try to sort of roughly work out that it's more than a 10% cache compared to the capacity total. I think one of the things around storage, I think we allude to, and I don't think it's included on this one, is that making sure that based on the resiliency level that you're going to have, that you have enough capacity disks. So one of the key recommendations, and I allude to it here, is to have 1 reserve disk per node of your capacity disks. And what this would allow is it means that if you're operating as normal and you get a capacity disk that fails, Storage Spaces Direct has the space available to reinstigate the resiliency level that you require. So if you have a three-way mirror and you lose a disk storage and there's a reserve disk in place, the storage spaces direct will start to use that space, move data around via storage jobs, so that any volumes which are impacted by that disk being lost are in the process of being put back to a three-way mirror. So there's 3 copies of that data, and that allows you to then and maybe the next day that you get a replacement disk, and when you insert that disk, what will happen is that an optimization job will run over the next sort of couple of days, which will then balance all of the data out again onto those disks. But what it means that you're not sitting with volumes at not optimal resiliency level whilst you're waiting for a replacement disk. Yep.
And especially with a replacement disk. So I had that with a customer. You can take equal from the shelf, either same size or larger. But what you should do is wipe it before you put it into the array. So we had the customer taking a spare disk from his shelf, putting it in the array, but someone put already some data on. Storage Spaces Direct will not take the disk because it's not deleting the disk because it's thinking that it could be a spare disk. It needs to know that it is a spare disk, and to know that, or to re-identify that as a spare disk, it must be wiped, completely wiped, empty, no file system, nothing on it, and then it would take it and put it in the storage pool.
Yep. So again, with that, it's recommended to have at least 1 reserve, but I think within the documentation mentions to go up to 4 reserve disks, and again, that's just to allow your system to be as optimal as possible. Most customers I work with have just go for a single reserve disk because they've normally got a 4-hour or next day turnaround time on replacement hardware, and they're quite content to wait that 4 hours or that to the next day for a replacement disk.
Or just do one thing, have a cold spare sitting on top of your rack, as we did in the past. Just have a spare one and just plug it in. That gives you another option.
Yep. So again, I think the next bit, I think again we alluded earlier about scaling. So that is it possible that you're only going to want to scale storage, and normally that is the requirement that you
that's 90% of whole scale scenarios we have is I need to have more storage. It's not more CPU or more memory capacity. Is really give you more storage.
Yeah, because I think at the moment data is king, and people are just gathering more and more data, and I think part of that's been the cost of storage just came down, so people have been.
We're all data hoarders.
Yes, that's it. So I'm sure there's legislations out there that stop some of that, but that's not for us to cover. But yeah, so what you need to look at is, do you have any free slots? Is it worthwhile maybe keeping a couple of spare disk slots per node is available for that sort of last minute expansion? But one thing that you do need to remember is that if you have six spare drive slots and you put in 10 terabyte disks, if you've got a 3-way mirror, that's only really going to give you 20 terabytes of usable storage, because your 3-way mirror with your copies. That's another thing that I've spoken with a couple of customers about, is that adding additional disks, just because you add an extra 60 terabytes of storage, that's then not usable, because if it's a 2-way mirror, you'll get around 30 terabytes of usable. But if it's 3-way mirror, again, it's going to be you would only get that extra 20 terabytes of storage, which is still considerable. But again, it's something just to consider, because if you've got no slots, as Flo's mentioned, you would need to buy a new server, and it needs to be matching. It needs to be all symmetrical. Is that hardware available? does your switch design allow for easily addition of a node? But then also you've got, because you're adding an extra node, means you're adding extra cores, and Azure Stack HCI is built on a core basis. So adding that extra is going to increase the licensing cost of the entire cluster.
So, yep. So personal recommendation here from our team is really go for the largest backplane you can have.
Yes.
So normally these chassis come with different flavors. So for the Dell R60 series, I think you have 4, 8, 12, something like that backplanes, and for the larger ones, even up to 24, 26. So really go for the largest backplane you can have. It may be an uptick from few $100, maybe. But on the long term, it gives you so much more expansion space. And as Steve said, it saves so many costs because adding another server, getting more switch ports, getting the cables, it's getting more running costs with the licenses and an ACR you will produce within our system. It's just 100 times or even more expensive than go for the big backplane and more and more lane capacity than yeah. So just buy the larger backplane and more lanes in the first place to save some money at the end.
So with that one, Flo, and this goes back to what you're saying with going for those, if you can go for those 2U servers, is that they're the ones that normally have the option to have a larger backplane. So, and again, with those, it comes more network slots, more the bigger backplane. So I know sometimes
you have even the option to add GPUs later on. So if
yes,
you have the if you, for example, have the requirement to build up some AVD or some CAT stations later in the enrollment in your POC phase, you can just order the required GPUs, put them into the systems, have your network cards still, because those are planned for high demand and high expansion and a lot of lanes and a lot of things connected.
Yep. So I think yes. So I think with that we've covered off the compute, so CPU, memory, the network, and the storage validation. One thing we haven't put in here, but I'm not sure if you have another video on this. It's just around the networking and the network switches for the validation of those. I'm not sure if that's a video that's available or coming soon.
We don't have one planned yet, but I think if the audience would like to, just leave us a comment, or we will do it maybe in any way. But at the moment, there's nothing in our pipeline for that yet.
Okay.
Maybe when watching it in a year, there will be something, but for now, it's really depressing as we did today, the bomb review. Just a few of my experiences at the end, or to do some, what we're seeing a lot, especially when it comes to density. Correct me if I'm wrong, Steve, but I'm seeing a lot more AMD now coming than Intel because of the high core and memory density, and that also with energy concerns in mind. So energy is becoming more and more expensive, especially in Europe. And what we see is the power demand on an AMD system is the same like we have on an Intel system, or an equal Intel chassis with an equal configuration. So I'm seeing more and more AMD popping up because of the higher density of cores, memory, and with that, higher density of disks in a much smaller energy footprint.
So I just think to build on that one as well is that a lot of with a lot of hardware, you're able to turn off some of those cores. So it may be that you're having a phased migration to Azure Stack HCI. So you may go AMD, but disable some of the cores, so it keeps the licensing costs down. But then as you add extra workloads, you can enable those additional cores. So it isn't something you recommend to do repeatedly, sort of enabling, disabling cores, but I have worked with a couple of customers where they've taken that approach, where they've gone for AMD and with a huge amount of cores, but they know that those number of cores aren't going to be needed for another 18 months or another 12 months. So they sort of disable some of the cores in the BIOS and to help reduce the initial cost of the license of Azure Stack HCI, and then they can turn those cores on as they need them as the environment grows.
Yeah, but that's a plus for Intel with the new scalable CPUs, as you can enable and disable cores on demand or features on demand with the new Xeon Scalables coming, or I don't know if it's already part in the 4th gen, but I think it's planned for the 5th gen, where we can really disable and enable features on demand with licenses or using an ID rack or something. So that's something we will maybe see in the future throughout the next years. Getting also these scalable approaches in our on-premise hardware, and that's again a thing why I recommend always to take the latest and greatest CPU generation, because all those features will sooner or later be enabled for those if they are announced on the beginning of the product line.
Yeah.
Yeah. So I think that was our bomb review.
Yep.
Steve,
thank you.
Thank you so much. We should do another one together at some point. For the others, subscribe our channel. I will most likely split that one up in a whole series, doing a few videos and a large video here. But yeah, leave us comments, and if you have more questions encountering your bomb reviews, just drop us a note. We can do an FAQ on that together, and have a great day and great time. Thank you so much, Steve.
Thanks.
Happy
Bye,
to
everyone.
have you.